Okay, now we're back with our chart once again. Here we're now going to go past the unit sales and we're going to look at how you develop the other financial data and how to calculate it. There's some basic math involved here, but I will try to explain to us in a conceptually easy to understand visually. Math is always math. You can always get to the formulas and so forth. But once you have the unit sales, the easiest and the most straightforward measure is profit. As I show in this chart, there is a per unit production cost. iPhone unit, for example, it's very easy to understand. The concept applies very well to it. And I come from semiconductor world, so per unit manufacturing cost is the measure that we use. In any case, profit is very simply, you take the per unit product cost, how much it takes to produce the total finished good, and then you multiply by quarterly shipped units and you get quarterly production cost. And then at the same time, you take the average selling price, or otherwise also called as price per unit, and then you multiply that with quarterly shipped units and you get the quarterly revenue. And as I show in this chart here, each vertical segment is 1 quarter, and instead of using the numbers and the line charts that I've showed before, here I want to show you in a qualitative, in a visual way, conceptually, how you want to maybe easier to remember. All the green stuff at the top, quarterly revenue. So very first column is when the product is launched. According to our model, it's sometime in Q3 of 2004 or 2014, something like that. Either way, so as the product starts to gain traction in the market, the revenue starts to increase. So the green box or green bubble is increasing in size every quarter, and at the same time, your quarterly production cost is also increasing, but not that much, because again, to say, like we said, the production cost is nothing but the number of units that you ship every quarter times the cost per unit, and we assume that for a reasonable length of time within this 12 quarter period, maybe for 5 to 6 quarters, the production cost or a product per unit product cost is the same. That may not necessarily be true, but for now we can go with that. And so all the red bubbles that you see going from 1 quarter to another, it is increasing because your number of units that you're shipping is also increasing, and the total cost, and these are dollar costs. And then profit is fairly straightforward. You just take the revenue and you remove the product cost from it, and you will get the profit, quarterly profit. So all the blue stuff that I show there is all the green minus red. So revenue that's coming in minus the amount that goes into making the product will become your quarterly product profit. This is not talking about company profit. It is only talking about this particular product profit. And then, so within the product purview, the gross margin is, again, that is another measure that is very important to maintain and to understand and to model. And so quarterly revenue is there, like we said before in this chart, and then quarterly product cost. And gross margin is a percentage number. It is nothing but revenue minus cost, and that number, resulting number, is divided over by the revenue number. And again, it is typical in general in the electronics industry, in the hardware industry, maybe 40 to 50% if you're manufacturing something. But if you're a retail or a seller like Fry's or Best Buy's or Suning or Gomi, all these stores, you tend to have a lot lower margins, because all you're doing is you're not manufacturing anything, you're not contributing to the intellectual property that goes into it. you are being a retailer or a distributor, so your profits, product related profits, might tend to be lower, very significantly lower numbers. But anyway, the point is that the gross margin, this is how you calculate the gross margin. In a much more interesting and a little bit more relevant to the justifying the business case is return on investment concept, and then how you calculate it. And for this return on investment, what you want to do is you take the same data, the profit and the cost, but instead of taking quarterly, you're going to take cumulative. So every quarter you're going to add the previous quarter's number, and then the next quarter you're going to add the previous the number. So basically, at any quarter you see that number, it is the total, let's say, cumulative profit. If I look at the Q3 or the third column, so that means the total cumulative profit that I got from this product in the lifetime until this third quarter is that number. And so if you see here the cumulative development cost, this is what you need to generate the return on investment. Remember way back when we talked about return on investment, it is more of how much company has invested in the development of this product, and then how much it is getting out of it as the revenue is generated. So the return on investment is calculated using the profit from the product sales. It is not using revenue numbers, it is using the profit numbers. And so remember that the gross margin is using the revenue and the per unit product cost measure, whereas the return on investment is using the profit and the development cost, not the per unit product cost. So you want to be cognizant of these differences. And as you would expect, the development costs will not grow forever, because once the product is finished its development stage, it's ready to be launched, there are no more development costs. So as a result, you will see in the development cost line, in second line, that circle, the size of the circle, the red circle, is not increasing. It pretty much stays the same. That means you're not adding any more costs, and that is again cumulative costs. So there are no new costs after the product is launched. And so the way to look at this is, obviously we expect the cumulative profit to enhance, to increase every quarter, and you just take one number and divide by the other. That's all there is to it as far as the very simplistic way, well, a simpler way of looking at the return on investment. Now, anyone with a financial background, financial subject background will definitely say that, look, there's a lot more to it than taking the profit and dividing it by the development cost. True. Agreed. But for a first level of an indication of where that break-even point is, meaning at what point you are starting to see positive returns, because as long as you are putting money into the product development and you have not finished developing it and you have not began selling it, all that money is going into it. Nothing is coming out of it, right? So only at some point you will start to see the profit coming out. And so that measure is a pretty good indication of what the business case will look like for your product. And so again, here I give the formula here. Return on investment is cumulative profit divided over by cumulative development cost. And you will see that, as you see, even by looking at this chart, you will see that at the beginning, the red, the denominator is bigger and bigger. And so this ROI, which is actually a number, which is going to be less than 1. But as you start to see that the development costs have frozen, they have not they have stopped expanding or increasing, and that's exactly when you will start to see profits start to increase. And so the numerator very gradually will start to increase and the denominator stays the same, and so you have the number at some point crossing over and becoming more than 1. And at a point where it cuts the 1.0, generally people refer to that as a break-even point. Break-even means, okay, so now you've sort of broken even. Now you got whatever it is that you've put into, you got that much money you have recouped, and so anything else that you get out of the product profit is the true profit. The true profit means true return, so to speak, return on investment. And so that is again one measure that you want to pay attention to, and you want to say is, so you got this return on investment, breaking the 1.0 barrier. You want to say how many quarters it takes for you to break that barrier. If the sales are very flat and the profit is very flat, then it's going to take that much longer for this break-even point, so many more number of quarters. But if the product is catching fire just like that, and then as soon as you've launched the product, you may start to see that profit starts to ramp up and you may hit the break-even point much quicker. So it depends on the product performance, product marketing, and customer acceptance, and everything else. So basically, and then the demand, obviously, if customers are waiting for you to release this product and then they're going to sort of jump in and then get the product, purchase the product, then obviously you're going to see much better result. And so basically that's how you do it. When I show you this chart, we have discussed unit sales, return on investment, how the development cost charts, the revenue, gross margin, and selling price, average selling price. It does change and trend over time. We can discuss why that is so. Maybe you offer some discounts for a period of time, or some promotional rebates or what have you. But in any case, pretty much, I think the business fundamentals, business justification fundamentals that I talked in this series of lectures are at the minimum what you need to start to convince yourself as a product manager whether you have a good business case or not. And so you can sort of put together this entire into a decent financial model as a spreadsheet, and then you may and then if you feel good that look, numbers are looking great and my ROI is much quicker, break-even point is coming up maybe 4 to 5 quarters or 3 to 4 quarters from the launch of the product, it's all good. But this is exactly when you have to test all your assumptions. You made some assumptions as to how much unit sales you're going to be able to make, but all of that is good. But what we need to do is to step into another activity that you have to do, and that is validating and testing all these assumptions behind this data. And so we will discuss that in the next lecture. So we'll see you next lecture. Thank you.